Hello students, welcome to Sreenath. In this video, we're going to learn the 11th chapter from 6th class CBSE Math. So which is nothing but Algebra students. Okay, so our chapter name is Algebra. So we're going to learn about this chapter students. So my name is Karthik Nune. We're creating videos on all chapters, on all videos, on all classes from class 6 to class 12. So please do subscribe our channel. So without wasting time, we're going to start this session students. So before we start our whole chapter discussion, let's see what are the concepts we are going to learn now. After that, we are going to learn each topic in detail. And later, the thing is about summary. So introduction students, in the introduction, what is meant by arithmetic and what is meant by geometry and what is meant by algebra. We are going to know the difference between these three things students. Next thing is matchstick patterns. So if here there are matchstick students, so using these matchstick patterns we are going to learn something new. So next thing is idea of a variable. So what is meant by a variable and how the idea of variable have come up. Next thing is more matchstick patterns. So here we see some more matchstick patterns. So because of it we will deduct some new things. So next thing is more examples of variables. So what are the different examples for variables? And after completing the discussion, there is exercise. You can do that students. So if you can't solve the exercise problems, comment below so that we will upload the exercise problems. Use of variables in common rules. So how we use the variables in our common rules, like from rules from geometry. In those rules, how we will use the variables, that is for perimeter of a square, perimeter of a rectangle, like that. And rules from arithmetic. In arithmetic also there are some rules: commutativity of addition of two numbers, commutativity of multiplication of two numbers, distributivity of numbers. In that rules, how we use the variables. So next thing is that expressions with variables. So using the variables, we will write some expressions. So how we can write those expressions and what are the information those expressions will give. So it is the expression, how it has formed. And next thing is that students, that is using expressions practically. So we are using those expressions practically. There is a practical statements, practical situations, practical problems, real life examples. We will express or we will correlate the practical situations in the form of a mathematical expressions. How we will do that task. So next thing is finally, what is an equation? So it is the basic thing regarding equation students. So in the higher studies students, in the higher classes, so there are so many lots of equations will come and you are going to learn about all those. Next thing is, after completing the equation, solution of an equation. So how to find the solution of an equation? So that is the thing students. So this is your whole chapter students. So starting from the algebra basics, you are going to learn what is an equation and how to find the solution of an equation students. So that is our whole chapter we are going to learn now students. Surely you will enjoy the session students. So just give me a like and start this session students. If you share with your friends also. So algebra. So students, we have studied about numbers. What are the counting numbers, what are the different types of numbers, integers, whole numbers, natural numbers, rational numbers, or like that, decimals, fractions, all this stuff. And we also study about shapes. So circle shape, square shape, rectangle shape, triangle shape, polygons, all these things. So the study about the numbers is called as arithmetic. And the study regarding the shapes is called as geometry. Then what is meant by algebra? What does algebra says? So algebra is nothing but the students, it is also a new branch of mathematics students. Algebra, new branch of mathematics. Is a new branch in mathematics students. In these algebra students, we will use variables, we will use numbers, we will use, sometimes we will express the shapes and their formulas in the terms of numbers, like that students. Morely we will use variables, which means morely we will use letters with numbers. This is the thing students. Why we use letters means, so if the number is given, it has fixed value, but if you represent a letter, so the letter may have any value, which means a letter is represented whenever we don't know the value. Whenever you don't know the perfect value, correct value, then we will assume it, just an assumption, just we imagine it with some letter, so that whenever we know the correct value, then we can replace that letter with that number, exact value, until you find out that number. We will represent it with a letter, so that we can do calculations easily. Okay students, so algebra main thing is that students, we will use letters, and in algebra we use these letters to determine unknowns, unknown quantities. So there are some unknown quantities, we don't know them, their true value, perfect value, correct value. So what will you do is we will assign some letter to that value. So we will do some calculations, do further, and finally we will find out that value, perfect value of that letter. Okay students, that is the thing. So since letter stands for numbers, operations can be performed on them as numbers. So here we use the letters, and we are discussing that these letters representing a lot of numbers. So any number can replace this letter. So which number to be replaced is we don't know. So until we find out that, we will some letters. So letters are representing the numbers here. So letters are representing the numbers. So what are the arithmetic operations we're doing on the numbers can also be done on the letters. That is the thing students. So finally the arithmetic operations on the letters will give rise the operations on letters. Gives rise to arithmetic expressions. Arithmetic expressions students. Okay, so that is the thing. So finally in this session, in this chapter, we're going to know what are arithmetic expressions and arithmetic equations, variables, algebraic equations, so not arithmetic students, it is algebraic equations, algebraic expressions, and finally they convert into the algebraic equations. So like that students. So this is all about the introduction to algebra students. So what is meant by algebra? Algebra is a new branch in mathematics. In that branch there are letters, and those letters represents the numbers, and why we use those letters to the why they represent some numbers. We don't know that numbers exact values. To find out those exact values, to find out those unknown quantities, we will use these letters, and as the letters are representing the numbers, finally we can perform the operations, normal operations on these letters, so that we will get algebraic expressions. So finally there you will get algebraic equations and solution to that algebraic equations. That is the thing, students. So now we'll start the next thing, that is matchsticks pattern, students. Okay, so we have completed this. So Amina and Sarita are making patterns using matchsticks. They are playing with matchsticks. So while they are playing with matchsticks, they have decided to make some simple patterns or simple letters using matchsticks. So they started their game, and they planned, they discussed finally and finalized to draw a letter L using matchsticks. So then immediately, so they have taken two matchsticks, and they have placed one in vertical and one in horizontal. So next, to form a letter, so next Amina has take another two matchsticks and put by the side of the first Sarita's matchstick. So again Sarita came up and take another two matchsticks and again draw letter L. The process goes on. If you see, first thing is this, secondly Sarita and Amina, next Sarita, Amina and Sarita, like that. So like that they are playing with the matchsticks, so that letter L they are drawing with the matchsticks. So then Appu comes in. So she looks at the pattern. So Appu's nature is always she questions. So she asks the girls, how many matchsticks will be required to make 7 L's? So Appu asks them. So she came and has seen there are matchstick, so there is 1 L, 2 L's, 3 L's, and so on, arranged like that. So Appu asked what she asked, how many L's required to make 7 L's, 7 L's in this pattern. So all of suddenly they start thinking. So Amina and Sarita are systematic. So what they are doing is they are adding more matchsticks to make more L's, like that, students, in the previous way. So like that they have already they have completed 3 L's now. So they have added 4, 5, 6, like that. And after that they have prepared a table. So in that table, number of L's formed in one box and number of matchsticks required to form that L. So at the first they formed only 1 L. So for 1 L, how many matchsticks they have used? They have used 2 matchsticks, students. Okay, so next they have formed 2 L's, that is why it is 2. And how many matchsticks they used? 1, 2, 3, 4. 4 matchsticks they have used. Next thing is they have formed 3 L's. How many matchsticks they used? So 1, 2, 3, 4, 5, 6. So 5. So if the process goes on, next for 4 matchsticks, what they observe is they used, so for 4 L's they have used 8, for 5 L's they have used 10, and for 6 L's they have used 12 matchsticks, and for 7 L's they have used 14 matchsticks, students. So after completing this table, Appu got the answer to her question. So what is the question? How many matchsticks required to make 7 L's? So that is, we require 14 matchsticks. So, and while writing this table, Amina realized that number of matchsticks is required is twice the number of L's formed. So if you observe, number of matchsticks required at every time is twice the L's formed. If you see here, there is 1 L. For that, we used 2 matchsticks. There is 2 L's here. For that, we have used 4 matchsticks. So every time if you see, this number is double of this. Okay, students. This number of matchsticks required is double of the number of L's formed. So if you see here, so 3 into 2, 3, if you doubles the 3, you will get 6. If you doubles the 4, you will get 8. If you doubles the 5, you will get 10. If you doubles the 6, you will get 12. And if you doubles the 7, you will get 14. And if you doubles the 8, you will get 16. So every time if you see here, what you will observe is that, students, so every time the number of L's formed and the number of matchsticks required is double of the number of L's formed. So finally, what is our conclusion? That, students, number of matchsticks required is equals to double, means 2 into number of L's. This is the thing they have observed, friends. So if you see from the beginning, if you see, students, here number of L's formed is 1. So that is 2 into number of L's formed is 1. So 2 into 1, which means how much? 2. So that's why here number of matchsticks required is how much? 2 matchsticks, if you can see here. So next thing, Appu came in and Appu asks how many matchsticks required to form 7 L's. So she wants 7 L's to be formed. So what is our thing is doubles the L's. So if you doubles the thing, you will get, that is 7 to 14. So we will require 17 matchsticks. If you see here also, there are 17 matchsticks. So like that, if you want 8 matchsticks, sorry, if you want 8 L's, then if you want 8 L's, then what we have to do is that 2 into 8 is what? 2 into 8 is 16, like that. So if you want 9 matchsticks, then you have to double it. Then you will get 18 matchsticks required. This is the session, friends. So I realized this thing, that is number of matchsticks required is equal to 2 into number of L's formed. The process goes on. So students, here number of L's formed, for that we have taken that represented with letter N. Okay, students, we are representing number of L's. Number of L's is equal to N. So every time if you see, the number of L's is changing. So every time if Sharanyu comes, how many matchsticks required to make 100 L's? How many, next time your friend may come, how many matchsticks required to make 200 L's, like that. So L is changing. So that's why we are going to represent that L with the letter N. Okay, students, this is the highlight of this session. So here we are introducing the letters. Why here we are introducing the letters means the numbers are continuously changing. So for a particular situation, particular number is enough. So if Appu comes and asks you the question, how many matchsticks required to make matchsticks required to make 7 L's? For that question, 7 matchsticks. Suppose if anybody comes and how many matchsticks required to make 10 L's. So in that situation, again it changes. The 7 changes from 10. So so every time you are going to draw the table and every time you are going to do the task is difficult. So we are making the process so simple. That's why. So sometimes 7, sometimes 10, sometimes 11, like that. So every time the numbers are changing. That's why we are representing instead of those numbers with a letter. We are assuming with the letter N. So if Appu comes in and asks for how many mastics required to make 7 L's? Then we are going to replace that letter N with 7. If somebody comes and asks you how many mastics required to make 10 L's, then we will replace the N with 10. If somebody comes in and asks how many mastics required to make 15 L's, then you will replace this N with 15. So that by simply replacing N with that numbers, what you get is, by simply multiplying it with 2, you will get the number of mastics required. So as you know, that number of mastics required is equal to 2 into N simply, or you can simply write it as 2N. 2N and 2 into N means the same. 2 and N are multiplying. So here you can't doubt, sir, it is a variable, it is a letter, how we can multiply it with a number, sir? If there is 2 into 2, we can say 2 2s are 4. If there is 2 into 3, we can say it is 3x. But here it is a letter, sir. How you will do the multiplication? So in the beginning of this session, I have already told you that, students, so that we are taking here letters, and those letters are not letters, and those letters are representing the numbers in particular situation. In particular situation, the number is sum. In another particular situation, the number will change. That's why we are using a a letter. So we can't 2 into N means, we can't 2 into N means also 2 in N means the same, multiplying, but we can't simplify it. So when we can simplify it, suppose if Appu comes and asks, Appu came 7 L's, how many? In that case, we will say that is 2 into N, that is 2N, that is equal to 2 into 7, which means 2 and 7 are multiplying. So that here we can multiply 7 and 2, but here we can't multiply it. So it represents the numbers, but just represents the operation between the numbers. So whenever you replace this variable, whenever you replace this letter with a number, then you can perform the operation. So 2 7s are 14. So 14 mastics are required. Like that the situation, students. So Amina tells her students that her rule gives the number of mastics required for forming any number of L's. So what is the use of this thing, students? We can say number of mastics required for any number of L's. Even though if you ask what is the number of mastics required for making 1000 L's, we can say simply within second. But if you want to do the same task by arranging like this, if you want to arrange 1000 L's like this, it will take so much of time, so much of work, so much of energy, so much of cost, so much of money, all are so much. So we have to smart now, students. So in order to become smart, we have to use shorter ways and smarter ways. So that's why, so by using this same thing, we can simply say 2 into 1000. If you want 1000 L's, that is nothing but 2 into 1000, which means 2000 L's. That is the case, students. So for N equal to 1, which means if you want 1 L, the number of mastics required is 2 into 1, that is 2. If N equal to 2, we require 4. If N equal to 3, we require 6. Like that, students. So Sarita says the rule is very powerful. So this rule is very powerful. So very helpful. Why? Because means even for 100, even for 1000, even for anything, we can say how many mastics are required. That is the thing, students. So now we study the idea of a variable. So how the idea of a variable came up, students? So from the previous example, it has came up. So previous example, now idea of variable. So from the previous example, we have came up with an idea of variable, students. So in the previous example, we have used a letter N instead of a number. Why? Means if you use a number, it will suit for only particular situation. But instead of a number, if you use a letter, it can fits to any situation. So if you use a number, you can only tell what are the L's required for only 7 L's. But if you use a letter N, you can tell what are the L's required, what are the matchsticks required for any else. So that is the advantage of this usage of letter N, students, which we called as variable. Okay, students. So number of matchsticks required is equal to 2n simply. So here n is the number of L's in the pattern, and n may have any values. N, letter N can take any values like 1, 2, 3, 4 and so on, maybe all natural numbers like that. Okay, students. So n is an example of variable. N is an example of variable. So we call n as n is nothing but variable, students. Variable means what, students? Whose value is changing, whose value is not fixed. If the value is fixed, we say that it is a constant. But if the value changes, we call that is variable. Its value is not fixed. It have any values. We call that as variable, students. So variable is represented by a letter. The word variable means something that can vary, that change. That is the thing, students. So can you understand the meaning of variable? So variable means whose value is changing, whose value is not fixed. So we will represent a variable with a letter, and the letter may take any values. We can replace it with any number. More matchstick patterns. Okay. So more matchstick patterns. Okay, students. So next, Amina and Sarita have become quite interested in matchstick patterns. Why they got so much of interest means, so because first they started their game with using matchsticks. After that they are no, so for anything, for any else, they can tell how many matchsticks required. So they now played the same game with another letter, that is the letter C. They tried to form a letter C using matchsticks. So they formed a single letter C with matchsticks, and next they have added one more C, added one more C, added one more C. So again they have formed the table, same procedure. So number of C's formed and number of matchsticks required. So for 1 C, 3 matchsticks are required. For 2 C, 6 matchsticks are required. For 3 C, 9 matchsticks are required. So after observing every situation in the previous thing, so number of matchsticks required is double the number of letters formed. Here number of matchsticks required is thrice the number of C's required. If you observe, students, so for 1 C, how many? That is 3 L matchsticks are required. For 2 C's, 6 are required. For 3 C's, 9 are required. So if we can write it as 3 into, so we can write it as 1 into 3, and we can write it as 2 into 3, and we can write it as 3 into 3. And for 5 C's, if you see here, 15 are required. So you can write it as 5 into 3. So if you observe, students, so for 1 C, 1 into thrice are required. For 2 C's, 2 into thrice are required. For 3 C's, 3 into thrice are required. For 5 C's, 5 into thrice are required. Like that for 8 C's, how much? 8 into thrice are required. That is nothing but 24. So and so on, like that if the process goes on. For 100 C's, if you want to make 100 C's, how many matchsticks do you require? So that is equal to 100 into 3. So that is 300 matchsticks are required. So simply so if you want to make for n C's, 3n matchsticks are required. Simply that is n into 3 for n C's, 3n matchsticks required. So finally here, what is the conclusion in the students? So number of matchsticks required is equals to 3 into number of C's formed. So if you represent the number of C's with a letter n, that is equal to 3 into n, that is equal to 3n. Number of matchsticks required is 3n simply. So if you want for single C, so n value is what for single C? Number of matchsticks required. Is equals to 3 into n, that is equal to 3 into 1, that is equal to 3. 3 matchsticks are required, students. So why? Because means n value is 1. So n is a letter we have used it here. That letter n is nothing but representing the number of C's formed. Here n value is continuously changing. Here n is a variable. So with the help of this, you can say for 1 C, even though for 1000 C's, if you want to make 1000 C's, how many matchsticks are required? So that is equals to 3 into n, that is equal to 3 into 1000, that is equal to 3000 matchsticks are equal. So it is a powerful tool, students. That is the case. 3n simply, students. 3 into n, like that. So here we can replace the n value. So next, Amin and Savita wish to make a pattern of f. Then they have found it to form a letter f. So similar way, students, for f how many matchsticks are required? 1, 2, 3, 4. So they for single s, for 1 f they require 4 matchsticks. Like that, if the process goes on. So you have to do this task, students. Do it by your own. So simply write this type of statement for this also. Number of matchsticks required equal to 3 or how much into n. Next thing, more examples of variables, students. So then Raju came and asked, sir, until now we have used the letter n. Why don't we use the letter m? So we can use letter m also, students. So there is nothing special to letter n. Only one thing is variables represented by letters. Just think. So letter may have any value. So we can use any letter. So like this m, l, n, any letter we can use. We can use any letter to represent variables. So we can use m, we can use l, we can use p, we can use x, we can use y, we can use z. Any variable we can use, students. Okay, so why thing is the students, variable is a number. Variable is a number whose value is not fixed. That's why you are representing it with some letter. Okay, students. So variable may have values y 500 like that. Variable is number, it is not fixed. Okay students, let us consider variables in a more familiar situation, students. So students went to buy notebooks from the school bookstore. Price of one notebook is 5. So students went to the school bookstore, students, and they have bought the books. So price of one notebook is equals to 5 rupees, students. Price of one notebook is 5 rupees. So Munu wants to buy 5 notebooks. So Munu came and Munu wants five books. And Appu wants 7. Sarah wants 4. So Appu wants 5. And Munu wants 5. Appu wants 7. And Sarah wants 4. So totally, how much money they have to carry to the school bookstore? How much money they have to carry to the school bookstore to buy the notebooks? What is the total money? Can you tell? What is the information we are having is price of one notebook is just 5 rupees. Okay students, for one notebook it is 5 rupees. For all these notebooks, how much total money it takes? So this will depend on how much notebooks the students want to buy, students. So for one notebook it is 5. So for one notebook it is 5 rupees. So if you want for 2 notebooks it is 10. If you want for 3 notebooks it is 15. If you want 4 notebooks it is 20. Always simple. For one notebook it is 5. For 2 notebooks, that is equal to 5 into 2. That is equal to 10. For 3 notebooks, 5 into 3. That is equal to 15. Like that, for 4 notebooks, that is 5 into 4. That is 20. Like that goes. So on, so on. For M notebooks, how much? That is 5 into M. 5M. Okay students, so number of books wanted is M, then total one is 5M, like that. So finally total cost in rupees is equals to 5 into number of books. If you represent the number of books with the letter M, then it is 5M. So if the Munu wants 5 books, what is the total money? That is equal to 5 into 5, that is equal to 25. Why? Since M equal to 5 here, number of books is 5. If Appu wants 7 books, what is the total cost? That is equal to 5 into 7, that is equal to 7 5 are 35. Why? Since here M is equal to 7, number of books is 7. And next Sarah wants 4. If Sarah wants 4 books, what is the total cost? That is equal to 5 into 4, that is equal to 20, since M equals to 4. So M is a variable. M is represented by a letter. Why? Because means it may take any numerical values. Here it has taken 4, it has taken 7, it has taken 5. That's why we represent variables with letters. So variables are nothing but numbers only, but we don't know exact value and the value will changes. That's why we express it with a common letter, like that students. And next thing is one more example if you want to take. There is a Republic Day celebrations in your school, students, and children are going to perform mass drill. So they stand 10 in a row. In a single row 10 people will stand. So the number of children will depend on how many children can there be in drill? Okay, so in a row, in a row there will be 10 students. So total number of students, what? It purely depends upon the total number of rows. So the number of children will depend on the number of rows. If you know the number of children, if you have to know the number of rows. So if there is one row, if there is only one row, the children will be 10. If there are two rows, for one row there is 10 children. For two rows, the children are 20, which is nothing but 10 into 2, or 10 into 2. For 3 rows, the number is 30, which means it is 10 into 3. So like that, if you goes for R row, for P rows, how many? That is 10P. So in your textbook it is given R students, but I have written P. So nothing to worry students. With you can represent it with any number of your choice, any letter of your choice. Why I didn't use the letter R means students? So here there is R, and next to it there is rows. So in the rows also there is letter R, so that you may confuse about the spelling. That's why I have used the letter P. So 10 rows for P rows, 10P students are there, like that students. So next, in all these examples seen for, the variable was multiplied with some number students. Okay, we have multiplied the variables with numbers, and in sometimes we can add something to the variables, we can subtract something from the variables also. So we can do all the mathematical operations like addition, subtraction, multiplication, division, all those things. What we do to the numbers is can be applied to the variable students. Okay, so we can add any number to the variable, we can subtract any number from the variable, we can multiply any number with the variable, we can divide with any number the variable. So treat the variable as a number, not as a letter, but the number may changes continuously. That is the only condition students. Here there is an example. Sarita says she has 10 more marbles in her collection than Amina. So Sarita, what Sarita is saying, I have 10 more than you. So in your class also some people tell, so I am having more than you, I am having this addition to you, like that. So Sarita is having 10 more marbles than Amina. So which means what? So Sarita has some marbles and Amina is also having some marbles, and the number of marbles of Sarita is equal to the is 10 more to the Amina. Suppose if Amina is having 10 marbles, how many marbles Sarita will have? Sarita will have 10 extra marbles. Okay students, so if Amina and Sarita, so if Amina is having 2 marbles, so how many marbles Sarita will have? Sarita will have 10 marbles extra, plus 10, then Amina. So it is 2 plus 10, that is equal to 12. If Amina is having 5 marbles, then what about the Sarita? Sarita will have 10 extra, then Amina. So that is 5 plus 10, that is 15. So they didn't give the information about how many marbles Amina having, but they give you that the marbles that Sarita is having 10 extra than Amina's marble. So for example, if you assume if Amina may have 2 marbles, then Sarita will have 10 extra. If you assume the number of marbles Amina having is 5, which is 10 extra. If it is 7, again 10 extra, 17. So students, every time 10 extra, 10 extra, 10 extra. So that is which extra? Amina's marbles plus extra. So we can write it is, if Amina having x marbles, then how much marbles then Sarita will have? Sarita will have obviously 10 extra. So x plus 10. So this is the situation students. So Sarita's marbles. So if Amina's marble is equals to x, so we are assuming, we don't know correct value, but we are assuming with the variable letter ex. So then Sarita's marbles are what we know is whatever the Sarita is having is 10 extra than Amina. So Amina is having x plus 10. That is the Sarita's marbles, friends. So in this expression, so this is an expression, we call it as algebraic expression. Algebraic expression. So in this expression there is a symbol plus, so which is an operation. Okay students, in some cases there is 10x, so there is multiplication between the 10 and letter x. Here addition, sometimes it may 10 minus x, sometimes it is x divided by 10. It is subtraction, it is division. So all these are acceptable, students. Okay, so why means, sir, there is a letter? No sir, means it is not a letter, students. It is the number only, but we don't know what the number it is, and in every situations the number will changes. So that's why in order to give up for whole equation, for any situation, we are representing it with letter. That is the thing, students. And one more thing, students, these expressions cannot be simplified further until the value of x is known. If you know what the number we have to substitute instead of x, then we can simplify it. Otherwise we can't simplify it. Use of variables in common rules. Use of variables in common rules. So students, we have understanding and learning how to use variables. So we are using our variables to some common rules. First thing are from rules from geometry. So there are some rules in geometry. In those geometrical rules, we are using the variables. First thing is perimeter of a square. Perimeter of a square. So if there is a square, students, we know square. So we know one thing is, in a square each side length is same. So if it is having 3 units, 3 centimeters one side, and every side is same. If it is having 4, every side is 4. Okay students, so if anybody asks you for perimeter, what you will do, you will add all these things. So we'll add all things, or perimeter is equal to sum of length of sides. Or and one more thing is, perimeter means sum of all lengths. This length, this length, this length, this length. That is called perimeter. Here it is square. So here every side is having same length. So that's why instead of adding this and this, simply we'll multiply with 4. So that is 4 into, if it is 4 into length of each side. Length of each side. So this is the formula, students. This is the rule basically. Perimeter of a square. Regarding perimeter is total length of the boundary. So if you consider it, there are 4 sides and each side length is same. So length of each side. So this is the perimeter, students. So if it is 3 units, we can say that is 4 into 3. If it is 4 units, it is 4 into 4, 60. So if we assume length of side is L, then perimeter of square that is equals to 4 into L, students. So perimeter of a square is nothing but 4L, where L is the length of the side. So finally students, because of using this formula, we can simply remember what is the perimeter of a square, 4L. What is meant by L? L means length of the side. So if you know the length of the side of a square, you can simply say that what is the perimeter of a square. This is the beautiful thing students. If you represent this letter with P, perimeter with P, that is P equal to 4L. Next thing is perimeter of rectangle. So it is somewhat similar to this only. But what is the thing is that students, in a square, all the sides are having equal length. But what about in the rectangle? So in the rectangle students, opposite side lengths are equal. So this side length and this side length are equal, and this side length are equal. So we call, if it is A, B, C, D, and we call this length as the length and represent with L, and this is called as the width, represent with B. So this is B and this is the B and this is B and this is B. So again, if you come up with the perimeter, it is nothing but total sum of lengths of all sides. So we have to add this side length, this side length, this side length, this side length, like that. So instead of students, there is an option. Why? Because this side length and this side length are same. So if you add AB, it is the line segment, BC is the line segment, CD is the line segment, D is the line segment. So it is one thing, it is one thing, it is one thing, like that. So length of this side students, length of this side, length of this side students, AB side. So you have to add L plus B plus L plus B. So there are two L's, so we can write it as 2L. There are two B's, we can write it as 2B. And there is 2, there is T, we can common it. Or we can simply write it. So finally perimeter is represented by P, say for P equal to 2L plus 2B. So it is the perimeter of a rectangle formula students. Okay, so what is L here? L is the length and B is the breadth. That is the case students. L and B are variables, their values may change. So because using this, you can find the perimeter of any rectangle. Using this, we can say the perimeter of a square for any square. Next thing are from rules from arithmetic. So in that thing students, commutativity of addition of two numbers. Commutative of addition of two numbers. Okay students. So we know this rule from arithmetic. What does it says? If 4 plus 3 is equal to 7, even if you change these numbers, that is 3 plus 4, it also gives rise the 7. And what more thing is 4 plus 3 is equal to 3 plus 4. So this is the thing. So if you add two numbers, it will give some result. Even if you interchange the numbers also, it will give the same result. And the both are equal. So this is called as the commutative of addition of two numbers students. This property we called it as. So commuting means interchanging students. So here we will use the variables for these students. We are writing then A plus B is equals to B plus A, like that. So what is the A and B? Where A and B are variables. So A and B are variable students. We may write any value, numerical value for A and B. So you may write 4 plus 3, 3 equal to 3 plus 5, even though you can write 2 plus 3 equal to 3 plus 2, like that. We can write any variable students. Next thing is commutative of multiplication of two numbers. Commutativity of multiplication of two numbers. Okay students, so this is the case. So we know that, students, if you multiply two numbers, 4 into 3, it will give 12. So even if you interchange the numbers, that is 3 into 4, it gives us same result. So finally 4 into 3 is equals to 3 into 4. So this is the conclusion, students. So 4 3s are how much? 12. 3 4s are how much? It is also 12. So 4 3s is equals to 3 4s. Thus this rule tells. So here also we can replace these numbers with variables using letters, so that it can applicable to any numbers. It will be easy to remember. So we are writing it as a cross b is equal to b cross a. So where a and b are what? Variables. A and b can take any values, 1 2 3 4 5 6. You can substitute, or we can replace the letter a with any number. We can replace the letter b with any number. So the formula this still holds. Why? Because means it is commutative of multiplication of two numbers. So next thing is distributivity of numbers. Distributivity of numbers. So what distributivity of numbers tells the students? Suppose if anybody asks you find out the 7 into 38 is how much, how you will do it? So you will do it that 7 into 38 is equals to 7 into 30 plus 8. So how will you do it? You will multiply first the 7 into 30 plus 7 into 8. So 730 is 210 plus 7 is 56. That is 266. Like that. 738 is equal to 260. So in this way we will do the task, students. So what is the thing here we are observing is that, students, these two steps are important steps. That is 7 into 30 plus 8, that is equals to 7 into 30 plus 7 into 8. These two things you have to remember. So here it is. If we can replace these numbers with letters. We can replace these numbers with letters. That is a cross b plus c. We are keeping same the operations, but we are just replacing the numbers with letters. That is a cross b plus c equal to a cross b plus a cross c. So this is the formula, students. So this is in the form of variables, so that it is very easy to remember and very easy to apply. We can substitute any number in place of a, b and c's. That is the thing, students. So next thing is expressions with variables. So what are the expressions with variables, students? So previously also we have seen expressions with variables, students, but we didn't identify them. So what we have done previously in the arithmetic. So like this examples, 2 into 10 plus 3. So it is one type of expression. That is mathematical expression, arithmetic expression. Arithmetic expression. The next thing is for this, that is 3 into 100 plus 2 into 10 plus 4. It is also another arithmetic expression. So here there are numbers and there is operations on those numbers. That's why it is arithmetic expression. So there is addition, subtraction, multiplication, division, all these there. Numbers are attached with those. Those are the arithmetic expressions, students. And some of our arithmetic expressions are 3 plus 4 into 5, 8 minus 7 into 2. So there are arithmetic operations between those the numbers. So there maybe we can form algebraic expressions too. So how algebraic expressions are formed? So we will form using variables. Here we are using what? Numbers. Here we are using variables plus numbers. And all we do is we will do operations like addition, subtraction, multiplication, like that on variable students. For example, first thing, first thing is we have taken 2n no? In the first beginning, number of L's formed is equal to 2n. So it is an algebraic expression. It is written as 2 into n no? So it is a variable and it is a number, and there is a operation called multiplication. There is an operation called multiplication. So this is an algebraic expression, students, using variables like that. So we can replace any letter with the variables, then we can solve it like that, students. So another example is x plus 10. It is a number, and again it is a variable, and again there is an operation addition here. It is an algebraic expression like that we can form. So we know that variables can take different values. So variables can take different values, students. So whenever we substitute the different values for the variable, this will be solved. Okay, students, like that. In that case only, these addition, subtraction, multiplication, all will be used, students. Okay. A number expression like can be immediately valued. So one more thing is the students, if you having a arithmetic expression like this, arithmetic expression like this, that is 4 into 3 plus 5. So we can simply calculate it, we can simplify it, we can immediately evaluate like that. 4 3s are 12 plus 5, that is equal to 17. But if you have an arithmetic expression like 4x plus 5, we can't do evaluate immediately. Why? Because there is a variable, we don't know the value of that variable. It is the unknown quantity. We have to know the value of this. It may takes any numerical value. So whenever you find out that numerical value, then you can simplify it. Suppose we have find out the value of x equal to 1, then we can replace that x with 1, that is 4 into 1, that is 4 plus 5, that is equal to 9. So in that process we can replace it. So until you know the value of that number, until you know the value of that variable, you can't simplify it. So whenever you know that number value, when that you know the value of that variable, you can do the task. So here are their expressions, students, and how they are formed. Here y plus 5. Y plus 5 means what, students? There is a variable y and there is number 5 and there is operation 5, which means 5 is added to the variable y. 5 is added to variable y, and there is t minus 7, which is meant by what, students? That here 7 is a number, t is a variable. So t is subtracted from, 7 is subtracted from t. And here there is 10a. What does it means? That a is multiplied by 10 and there is x by 3. That x is divided by 3. Like that. Here minus q. So q is multiplied by minus 5. Like that, students. So some other is here. If they have given you the statement like this, 12 subtracted from z. 12 subtracted from z. So 12 is subtracted from what? From z. So first you have to write z, and from it 12 is subtracted. So that is z minus 12. And 25 added to r. So 25 added to something. What? For r, 25 is added plus. So p multiplied by 16. So for 16, p is multiplied. And y divided by 8. And for y, it is divided by 8. Like that you have to write, students. So Sarith and Amina decide to play a game of expressions. They now want to play another game. Previously they have played the games with using matchsticks. Here they have wanted to play game with expressions. So they take the variable x and the number 3. They take the variable x and number 3 and see how many expressions we can make using it. So this is a task for you also, students. Just take x and 3. Using both these things, how many expressions can you make? So there is a one condition, that is the condition is that they should use not more than 1 out of 4 number operations. They have to use only one operation. So only one operation, like addition, subtraction, multiplication and division. So there are only 4 mathematical operations. You have to use only one operation, and you have to use both variable x and number 3. You have to do this task. How you will do this? How many expression will you get? So we can say that is we can add them, we can separate them, we can multiply them, we can divide them. Like that you will get, friends. So 3 by x, like that also you can do this, friends. Now there is another game. There is combination of 3 y, 3, 5. You can use y, you can use 3, you can use 5. And condition is that, students, not more than one operation of addition or subtraction and one operation of multiplication or division. So here we have to use whether addition or subtraction, addition or subtraction, and multiplication or division. So what does mean means you have to pick up one operation from both of these, and you have to pick up one operation from both of these, or you have to pick up one operation from both of these and you can left it, or you have to pick up only one of operation from both of these and you can left it, and you may use both 3 or only 2, like that, whatever choice. How many expressions will you get? So try it by your own, students. There are some examples in your textbook. Y plus 5, yes, it is allowed. Y plus 3, it is allowed, like that. So next thing is using expressions practically, students. So in our daily life, in our practical situations, we use expressions, students. So there is a situation, students, described in natural language. Sarita has 10 more marbles than Amina. So it is a natural situation. Sarita is having 10 more marbles than Amina. So how we will represent it practically, mathematically, algebraically? So how many marbles Sarita is having? We don't know, but she is having 10 extra, 10 plus than Amina. Then how many marbles Amina is having? We don't know. So Amina, we don't know. Whenever there is unknown quantity, whenever there is unknown term, we have to take that as with variable. If you don't know the value, then take that as a variable. So Amina marbles. How many marbles Amina is having? We don't know. Whenever there is we don't know term, whenever there is unknown quantity, we represent that unknown quantity with a letter, represent with a variable. So Amina is having marbles x. Then how many marbles Sarita is having? What we know is Sarita is having marbles 10 extra than Amina. How many Amina is having? Amina is having x and 10 extra, 10 added to Amina's, that is x plus 10 marbles. So it is the expression, algebraic expression, students. So because she is twice as old as Raju, because she is twice as old as Raju. So what is the old of old? How old is Raju, students? What is how many years Raju is having? We don't know. But how many years? Because she is there is no information. But he is twice the age of Raju. So what is the age of Raju? We don't know about Raju's age. So that's we are taking it as x. So then we can say that is because. What is the because is? That is twice as Raju, which means multiply 2 into x. Like that, students. Okay. Now here. So previously we have converted the situation into expression. There is a situation and there is same like the students. How old? So here I will, years already we have discussed about years. The price of wheat per kg is 5 less than the price of rice per kg. So can you solve it, students? What is the price of wheat per kg? Can you know what is the price of wheat? We don't know, but what they have given is that it is 5 less than the price of rice. So price of wheat is 5 less than, which means which is less 5 than the price of rice. Will you know the price of rice? We don't know. So we are taking the price of rice as P. We don't know about it. Then what is the price of wheat? They have gave you information that is 5 less, which means 5 is subtracted from price of wheat, that is P minus 5, like that, students. So speed of a bus is 10 kilometers per hour more than the speed of a truck. So what is the speed of bus? Correct exact value is not given, but it is 10 kilometers per hour more than speed of truck. Then what is the speed of truck? We don't know. So whenever we don't know speed of truck, we don't know about it, so we are taking it as y kilometers per hour. And what about the speed of bus? Speed of bus is 10 more, which means 10 more the truck. So truck is having y plus 10 is 10 extra, adding 10, that is kilometers per hour, like that, students. So we have converted the practical situations into algebraic expressions. That is the thing, students. So finally, what is meant by an equation? So we have understood what is meant by an algebraic expression. What it is? Expression. So it is the time for equation. So it is the time for equation. What is meant by equation? So we will go to the previous thing, just how they have formed the matchstick patterns using the L's, students. So in those things we know, so number of matchsticks formed is equals to the 2 into n, where n is the number of L's formed. So Appu is always thinking differently. She always asks questions. So she asks, we know how to find the number of matchsticks required for a given number of L's. So previously how many matchsticks required? So this is the question of Appu, students. How many matchsticks required for 7 else, like that. So we can say that it is equals to 2 into n, where n is the number of C's, where n is number of L's formed. So here she asks quite differently to it. So how many L's are formed by using 10 matchsticks? So previously she has asked how many matchsticks required for some amount of for 7, like that amount of L's. Here they are asking how many L's formed for using 10 matchsticks, by using 10 matchsticks. The question is quite opposite, students. Okay, students, question is quite opposite. So how many L's are formed if the number of matchsticks given is 10? So this is also same situation, students. So given the number of matchsticks is, so basically if you know how many matchsticks required is 2n. Matchsticks required is 2n according to the formula. Here she is asking for, she has given 10 matchsticks, so it have to equal to 10. So can you understand, students? So previously how many matchsticks required is 2n and number of matchsticks is 10. So that's why we are equating 2n to 10. So here what is the n? N is how many L's formed. We don't know about it. That have to be find out. That's value has to be evaluated. So we have to take the value of n such that this situation is satisfied. So we have to take different values for n. Take different values for variable n. So we can take n equal to n equal to 2, n equal to 3, like that. So we will go and substitute, replace the n value with 1, 2, like that. So whenever you are substituting the value, that equation has to be satisfied, the condition has to be satisfied. So 2 into n must be equals to 10. So for what value of n this will equals, obviously we will do it by trial and error method. We are taking n equal to 2, then 2n equal to 4, n equal to 3, 2n equal to 6. Does it the condition satisfied? No. Why? Because 2n must be equals to 10, but 2n is here is 4, so not. Here 2n is 6, we want 10, so it not. 2n equal to 8, but we want 10. 2n equal to 10, we want 10. So it is the condition matched. What is the condition matched? Yes, whenever n is 5. So whenever the n is 5, this condition is matched. So number of L's formed using 10 matchsticks is 5, like that, students. So there is another example. Balu is 3 years younger than Raju. Taking Raju's age to be x years, then Balu's age is x minus 3. In this case also you can do the same thing. So an equation like the above is a condition on a variable. Equation is nothing but equation is condition on a variable. Equation nothing but variable. It is satisfied only for a definite value of the variable. So equation is a condition. Equation is nothing but equation is a condition on a variable, and it is satisfied for only for definite value, only for a definite value of variable, only for a definite value of variable, students. Okay, so if you take 2n equal to 5, it is 10, it is satisfied for n equal to 5 only, like that. Value of variable is n. So students, here there is we call this as the equation, and this is the value of variable, this is variable, and there is equal sign between two sides. So we call left of the equal sign is LHS, right of the equal sign is RHS. What is meant by LHS? Left hand side. What is meant by RHS? Right hand side. So whenever the condition is that, students, left hand side values must be equals to right hand side, then only we can represent there is a equal sign between them. So what is meant by an equation is that, students, in that equation there is a left hand side and right hand side, and there is a equal symbol between the left hand side and right hand side. So in that situation only it will happens. Okay, students. So for example, the statement 2n is greater than 10. So 2n is greater than 10. Is it equation? No. Why? It is greater than symbol is there. We must have equal symbol. 2n is less than 10. Is it equation? No, it is not. X minus 3 is less than 11. Is it equation? No, not at all. 8 minus 3 is equal to 5. Is it an equation? Yes. Why? There is equal to symbol, and when the left hand side value is 8 minus 3, which is 5. Right hand side also 5. Like that, students. So x plus 20 equal to 70. Is it true or not? Is the equation or not? Yes. 8 into 3 equal to 25. No, it is a numerical equation. It is not algebraic equation. Algebraic equation must have a variable like this. 2p greater than 30 is not. 20b equal to 80. Yes, there is a variable and there is equal sign. Fill in the blanks as required. X plus 10 equal to 30. Variable is like that. So 3n equal to 20. It is a variable. So it is the equation. And what is the variable here? N. N is the variable. Next thing is solution of a variable, students. Solution of an equation. What is the solution, students? If 2n equal to 10 is this equation, what is the solution to that equation? So students, it is nothing but the value of the variable, the value of variable for which the equation satisfied, for which the condition satisfied is the solution of the equation, students. So for example, 2n equal to 10, n value is equals to 5. Whenever the n value is equal to 5, this condition is satisfied, this equation is satisfied. So this n equal to 5 is the solution of the equation, students. The value of variable is the solution. That is the thing, students. X minus 3 equal to 11, students. What is the solution to it? So whenever you substitute the x value is 14, then this equation is satisfied. So 14 is the solution, like that, students. So we will do this by trial and error method, students. Here there is an equation x plus 10 equal to 30. What is the value of the variable, students? So if you substitute the value as 10, x value is 10, does the condition is satisfied? No, then it is not a solution. So if you substitute 30, it is not solution. If you substitute 20, yes, it will satisfy the equation. So it is the solution. Like that you have to do the things, students. So that is it, students. Our chapter is completed. Finally, our chapter is completed. So hope you have understood well, students. So don't forget to subscribe Sreenath Academy, Sreenath YouTube channel, students. So please follow on Instagram and join our Telegram channel, students. Feel free to comment below if you have any doubts. So like and share our video, students. So without wasting time, students, we are going to see the summary of the whole chapter, students. Algebra, students. So algebra, what is meant by algebra? So numbers, arithmetic, shapes, geometry. Algebra is a new branch of mathematics. We'll discuss about the letters in this, and the letters are unknown values, and they're used to form operations also, students. So by using these, students, by using single pattern, we come up with we need some variables, and finally idea of variable. Letter n represents, so variables are represented by letters, and variables are nothing but the numerical values, so whose values are not fixed, whose values are continuously changing. So idea variable, more matchstick patterns by doing it. So we will finding some expressions, students. So variables, we can take any letters for the variable, students. There is nothing problem in it. And after that we have find out use of variables in common rules. We are using the variables in common rules, students. That is for, so in the geometry, students, for finding perimeter of a square, we using that it as perimeter equal to 4L, where L is the variable and L is the length of the side of a square, students. And perimeter of a rectangle is equal to 2L plus 2B, students. Here L and B are the length and breadth of the rectangle, students, and L and B are the variable, students. And for arithmetic, students, so commutative of addition of two numbers can be represented using the variables, that is a plus b equal to b plus a, and commutative of multiplication of two numbers will be represented as a cross b equal to b cross a, and distributive of numbers is represented as a cross b plus equal to a cross b plus a cross c, like that, students. So next thing is expressions with variables, students. So what are meant by algebraic expressions, students? So algebraic expressions, algebraic expressions, students. In that expressions, there are variables, students, and mathematical operations like addition, subtraction, and multiplication, division between all variables and numbers, students. Okay, that is that regarding about algebraic expressions, students. So next thing is equation, students. So what is meant by an and how to express the algebraic expressions practically? There is a situation, and there is, from those situations we have deducted the algebraic expression, students. These are the examples of that. So next thing is that, students, equation. What is meant by equation? So equation must will have the, so equation is a condition on a variable, students. Okay, so it is satisfied for only one definite value of variable, students. So in a equation there is equal symbol. Okay, students, and there is a variable, and to the equal symbol, left hand side is called LHS, right hand side terms are called right hand term, and left handed sometimes values must be equal to right hand term, then only we can say it is a equation. So equation is nothing but a condition, students, on variables. Next, solution. So what is the solution of an equation, students? If there is an equation like that, there is a variable, and the variable value of that variable is the solution of the equation, students. Okay, that is the thing. So that's it, students. So our summary is also completed, students. So have a nice day, keep smiling. Bye bye, students.